All right, so far we've all done addition reactions, but there are actually other things we can do with alkenes. And so one thing that we can do with an alkene is we can cleave it oxidatively. So we can take this alkene and just totally break it up into two products right here, right? Where now they've all both been oxidized, right? This carbon here has lost electron density because it's next to a more electronegative element, and so it's been oxidized, right? So what reagent do we use? We use something called ozonolysis. And so what we have here is some kind of alkene. We add some ozone to it, which is O3, and then you can add a number of different reagents. One of the popular ones is zinc and water. It's a mild reducing agent. Think zinc here, it's in its zero oxidation state, and so it'll lose electrons, so it'll reduce something else. And so if we take a look at this mechanism, we have our alkene, and then we have ozone. Think about the structure of ozone. Our alkene will attack the doubly bound oxygen, or really they're the same thing. This will bounce over here, and then this negative charge will go ahead and back and attack our alkene. And so what this does is adds essentially this 5-membered ring with 3 oxygens across the double bond. And then after that, a rearrangement occurs. We won't worry about the mechanism of the rearrangement. It's just not that important, but it does rearrange. Into another 5-member ring with 3 oxygens, but now 1 less oxygen-oxygen bond. And then once we're in this kind of oxidized form, we can add some kind of reducing agent. And what that does is give us our final product. And so if we think about cleaving this double bond right here, we'll have this component right here. And now we just replace where it was a double bond C with a double bond O. And then just do the reverse on this other side as well. Right, where's the double bond C? Now it's a double bond O. And so you can see our products here are aldehydes and ketones. However, if we wanted to oxidize this further, we could actually do that as well. So for example, if we have the same alkene, but in this case, instead of adding the ozone, we're going to add some potassium permanganate and some acid. Or we're going to add some ozone. But instead of adding a reducing agent like the zinc and the water, we're going to add an oxidizing agent like hydrogen peroxide. And so this will fully oxidize the components. And so this part of this component will stay the same. It'll still just be a ketone. But then over here, you can see we have a hydrogen here. And so that component is going to get switched out. Instead of a hydrogen here, we're going to have an OH here. And so you can see our products here, instead of being aldehydes and ketones, they're ketones and carboxylic acids. But we need the extra H, right? Your alkene has to have an H in order to form a carboxylic acid, right? So only if this extra H is available. So if you don't have an extra H available, even if you use ozone and then followed by an oxidant, you'll still end up with just your ketones, right? You need the H in order to make them into carboxylic acids.